In the vast, dusty silence of the Baikonur Cosmodrome, there lies a wreckage that tells a story not just of engineering failure, but of an empire's final, desperate gasp. It is the ghost of a vehicle built to conquer space, yet ultimately conquered by history. This is the story of the Soviet Buran Space Shuttle. For the architects of the Soviet military-industrial complex in the 1970s, the greatest threat wasn't a nuclear missile. It was the American Space Shuttle program. Moscow did not see NASA's orbiter as a purely scientific endeavor. They saw a colossal weapon capable of flying over the Soviet Union, deploying military hardware, or even, in a terrifying scenario, snatching Soviet satellites right out of orbit. They saw a mirror image of their own paranoia. The response was immediate and immense. Build our own. The Central Committee of the Communist Party issued a non-negotiable decree. The Soviet Union must develop a reusable spacecraft that could directly counter the American shuttle. It was a matter of ideological survival. No cost was too high, no engineering feat too complex. The final design of the Buran was eerily similar to the American orbiter. White tiles, massive wings, and the distinctive bulbous nose. This wasn't coincidence, it was deliberate policy. The Soviets believed that for Buran to neutralize the American threat, it needed to be functionally and visually identical, ensuring parity in the eyes of global intelligence. This mandate, however, forced engineers to bypass decades of independent Soviet space research in favor of a rushed reverse-engineered path. Despite the visual similarity, the Soviet challenge was far greater. Unlike the U.S. design, which relied on external boosters, the Soviet system demanded that Buran be fully integrated with a massive, dedicated heavy-lift rocket, the Energia. The Energia was a marvel in its own right, a behemoth that could deliver over 100 tons to low Earth orbit, designed to be the backbone of future Soviet space dominance. The single largest technical hurdle was the thermal protection system. The American shuttle used highly specialized, fragile tiles. The Soviet engineers spent years and billions of rubles developing their own thermal tiles, many of which had to be hand-cut and individually fitted to the Buran's fuselage. The process was slow, expensive, and a constant logistical nightmare, consuming countless man-hours and a desperate race against the clock. The cost of building Buran, Energia, and the entirely new infrastructure to support them, massive new launch pads, tracking stations, and transportation systems, is estimated to have exceeded 20 billion rubles, conservative 1980s estimate. This parallel space program was a staggering drain on the Soviet economy, which was already crumbling under the weight of its own inefficiency. The Buran project was, from its inception, the Soviet Union's most expensive and desperate architectural and engineering rebuttal. It was a project born of fear and fueled by the belief that money and manpower could instantly replicate a complex foreign technology. But in the late 1980s, money was running out, and the political ground beneath the Soviet Empire was starting to crack.
For the Soviet leadership, relying on slow, organic scientific development was not an option. The American lead in reusable spaceflight was seen as an existential military threat, demanding an immediate, drastic response. That response was formalized into a vast, secretive program of industrial espionage. The Central Committee did not just demand a Soviet shuttle, they demanded the blueprints and secrets of the American one. The KGB was deployed globally, initiating a multi-year effort to acquire everything from technical specifications of the heat shield tiles to diagrams of the advanced avionics systems. This wasn't minor spying, it was a state-sponsored campaign to harvest the entire technological architecture of the U.S. Space Shuttle program. The goal was speed, but the result was systemic dependency. Every piece of intelligence stolen had to be interpreted, reverse-engineered, and adapted to fit the Soviet industrial base, a process that was both inefficient and astronomically expensive. The data acquired by KGB agents confirmed the visual resemblance, but the details revealed a dangerous truth. The U.S. Space Shuttle was a highly integrated, complex machine built on technological foundations that the USSR simply did not possess. For instance, the shape of the Buran, specifically the geometry of its wings and fuselage, had to be near identical because Soviet intelligence believed the external shape was key to the American orbiter's glide path and stability during atmospheric re-entry. They invested billions to meticulously match the exterior, even though Soviet designers later realized their own aerodynamic models could have used a simpler, less expensive design. They were locked into a technological lie dictated by paranoia. This obsession with parity was the Buran's fatal flaw. The Soviet scientists were constantly battling the political necessity of copying against the engineering logic of designing the best vehicle for their own system. Two specific components proved near insurmountable for the reverse engineering teams: the flight control software and the thermal protection system. The American shuttle relied on an incredibly sophisticated, redundant digital flight control system. The Soviets, whose computing technology lagged significantly behind the West, struggled desperately to replicate this capability. The Buran required 5 onboard computers running simultaneously, an immense feat of Soviet engineering, but it remained heavy, cumbersome, and inherently reliant on hardware that was often difficult to source domestically. Furthermore, the highly specialized silica thermal tiles of the American shuttle were a guarded secret. The Soviets managed to analyze samples, but spent vast sums developing their own equivalent, manufacturing over 38,000 individual tiles for the Buran orbiter. Each tile was unique, needing individual calibration and placement, consuming a massive portion of the program's budget and timeline, all to replicate a system that was conceptually brilliant but logistically devastating. The greatest structural divergence, however, became the biggest source of the burden: the massive Energia rocket. Unlike the U.S. shuttle, which had its main engines on the orbiter itself, Buran had no main rocket engines. Instead, it was carried into orbit atop the Energia. While this design choice was technically superior, the Energia could be used for other heavy payloads. It compounded the financial difficulty. They were not just building a shuttle, they were building the world's most powerful launch vehicle simultaneously. The two projects consumed vast tracts of the Soviet economy, diverting manpower, steel, and funds from dozens of other crucial scientific and military projects. By the early 1980s, the Buran project was no longer a matter of simply building a reusable spacecraft. It had ballooned into an unsustainable effort to maintain global technological parity at the expense of national solvency. The technological achievement was undeniable, but the economic foundations were collapsing.
The Buran project was not just about building a spacecraft. It was about building an entire self-sustaining space infrastructure from the ground up, capable of rivaling NASA's massive complex at Cape Canaveral. The centerpiece of this effort was the Baikonur Cosmodrome in the Kazakh steppe, which had to be fundamentally transformed. The Soviets built a specialized climate-controlled assembly and testing complex, or MIK, large enough to house multiple orbiters and Energia rockets simultaneously. This structure alone was one of the largest buildings in the world, a monument to the regime's belief that scale equals success. New launch pads, capable of withstanding the immense thrust of the Energia, had to be constructed at staggering cost and speed. These weren't mere upgrades, they were new facilities built with the most advanced, expensive materials the Soviet industry could procure. The political imperative was to ensure the infrastructure could support a frequent launch schedule mirroring the operational capabilities promised by the Americans. This required a level of investment and logistical organization that stretched the planned economy to its absolute breaking point, draining resources from vital defense sectors and civilian infrastructure across the entire Union. Moving the massive components of the Buran and the Energia was an engineering challenge almost as complex as the flight itself. The components were fabricated across the vast Soviet Union, the orbiter built in Moscow, the massive external tanks in other distant factories. To transport the full-sized Buran orbiter, a vehicle wider than most highways, the Soviets designed and built the Antonov An-225 Mriya, which, upon its creation, became the heaviest and largest aircraft ever built. The image of the Buran piggybacking on the Mriya, lumbering across the Soviet skyline, was the ultimate display of technological bravado, but it masked an insane logistical expense. This wasn't merely a plane, it was a bespoke, multi-billion ruble necessity created solely to solve a problem caused by the scale of the Buran project. For ground transport, specialized railway cars and massive road convoys were engineered to navigate the thousands of kilometers between factories and Baikonur. Every component of the system, from the rocket fuel to the smallest avionics chip, represented a logistics chain operating at maximum tension, ready to snap under the smallest disruption. The entire process was a desperate, choreographed ballet of extreme engineering that underlined the project's unsustainability. The sheer manpower consumed by the Buran program remains almost unbelievable. It is estimated that over 1.2 million engineers, technicians, and factory workers were employed across 1,200 enterprises throughout the USSR, all tied to the success of the Buran and Energia. This was not just a space program, it was a vast employment machine fueled by state decree. Thousands of families were relocated to the arid steppes surrounding Baikonur, creating new military and scientific cities entirely dedicated to the shuttles. The political pressure on the lead designers, like Valentin Glushko, chief designer of the Energia, was immense. Failure was not an option. Deadlines were enforced by political mandate, leading to compromises in materials and quality control that would prove fatal later on. This enormous consumption of human capital and economic output was occurring precisely when the Soviet economy was entering its terminal decline. Every ruble spent on the Buran was a ruble taken away from necessary agricultural subsidies, housing projects, or consumer goods, stoking the internal dissatisfaction that would soon boil over. By the mid-1980s, the Buran was approaching its maiden flight, but a new, unforeseen threat had emerged: political reform. Mikhail Gorbachev's policies of perestroika and glasnost were beginning to expose the immense inefficiencies and financial black holes within the Soviet system. The staggering budget of the Buran, which was kept highly classified, could no longer be hidden from increasingly critical eyes within the Politburo. Questions began to arise. Did the USSR truly need a reusable spacecraft that simply mirrored the Americans? Where was the military necessity now that tensions were easing? The Buran, designed to project Soviet strength externally, was now becoming a symbol of internal decay and financial mismanagement. Though the final launch sequence was already underway, the political will, and more importantly, the unlimited budget that had birthed the Buran, were rapidly dissolving. The massive infrastructure stood ready, but the empire that commanded its use was breathing its last breath.
By late 1988, the political climate had turned glacial, but the engineering work had reached a fever pitch. The Buran orbiter, the first in its class, was mated to the immense Energia booster. Facing the reality of economic crisis and political uncertainty, the Soviet leadership made a decision that, in hindsight, marked the project's true technical triumph. The maiden flight would be unmanned. This was a feat the American Space Shuttle was never designed to achieve. While the U.S. system required a crew for launch and landing, the Buran was equipped with a fully autonomous, state-of-the-art fly-by-wire computer system capable of managing the entire mission, from orbital insertion to atmospheric re-entry and a perfect runway landing. This decision was driven partly by safety, but primarily by the Soviet desire to demonstrate technological superiority in robotics and automation. The complexity of this flight software, developed against the backdrop of inferior Soviet microprocessors, represented a monumental achievement for the project's designers. The goal was to prove unequivocally that the Soviet system was not merely a copy, but an advanced evolution of the reusable spacecraft concept. The world was watching closely, aware that the stakes were higher than ever. The date was November 15, 1988.
High winds threatened to scrub the mission, but the immense political pressure and the dwindling budget timeline left no room for delay. Unlike previous Soviet space launches, which were shrouded in secrecy, the Buran launch was heavily publicized. It had to be. It was the last great propaganda display of a dying empire. As the towering Energia rocket, the most powerful non-nuclear vehicle the world had ever seen, ignited its 4 powerful liquid propellant Zenit boosters, the Earth shook across the Kazakh steppe. The launch was flawless. The Energia flawlessly carried the Buran orbiter to its designated orbit. It achieved 2 perfect orbits of the Earth, navigating the void entirely under the command of its onboard computers. The mission was short, lasting only 206 minutes, but every second was a demonstration of a highly successful, fully automated space platform. The question was no longer if they could build it, but if the state could afford to use it. The most crucial and impressive part of the mission was the landing. As the Buran separated from the Energia and began its descent through the atmosphere, a heavy crosswind buffeted the massive glider. The onboard flight computer had to make instantaneous, complex corrections. The Buran's autopilot system performed a complex high-speed maneuver, adjusting its approach to the runway at Baikonur. It touched down perfectly, stopping precisely where it was programmed to, demonstrating a level of automation and precision that put it decades ahead of its American counterpart at the time. The successful landing was met with a brief, ecstatic moment of triumph among the engineers and designers. They had done the impossible. They had built a fully functional, superior, reusable spacecraft in half the time and under crushing political stress. For a fleeting moment, the Soviet space program had reclaimed its technological crown. The headlines screamed of success, and the engineers celebrated a victory bought with decades of toil and limitless state funds. The irony of the Buran's success remains one of the greatest tragedies in aerospace history. On November 15, 1988, the Soviet Union proved it possessed the technological genius to beat the US in autonomous, reusable spaceflight. But by then, the empire itself had run out of time and money. The victory was immediately overshadowed by the rapidly deteriorating economic situation and the accelerating pace of perestroika. The political leadership was already looking for places to make massive, painful budget cuts, and a multi-billion ruble space program, which had only military applications and no clear commercial future, is a prime target. The Buran was wheeled triumphantly into the hangar, intended to be quickly prepped for its next flight in 1990. Instead, it entered a state of suspended animation. The empire's final technological breath was a perfect flight that would never be repeated. The Buran was ready for orbit, but the Soviet Union was not.
The success of the unmanned flight in November 1988 was, paradoxically, the beginning of the end. The engineers had proven the technology was sound, but their very success demanded an immediate, massive infusion of cash to prepare the orbiter for its next flight and begin serial production of the next 4 planned orbiters. That money simply did not exist. The cost of developing, testing, and operating the Energia Buran system dwarfed the cost of all previous Soviet space programs combined. It required not just funds, but dedicated resources, rare materials, advanced microprocessors, and the unwavering commitment of the state's industrial capacity. That commitment was now gone. The state was struggling to manage massive shortages of consumer goods, escalating strikes, and a collapsing currency. To continue the Buran program would have meant accelerating the internal economic collapse. The financial burden was too heavy, even for a state historically dedicated to maintaining military and ideological parity at any cost. By 1989, the political will had evaporated. Mikhail Gorbachev, focused on salvaging the Soviet economy through perestroika and negotiating arms reductions with the West, had no interest in maintaining a multi-billion ruble vanity project designed to combat a threat that was rapidly receding. The project had been justified as a military necessity, a strategic response to perceived American threats. With the geopolitical climate softening, that justification was dissolved. The Buran program was moved from the highest priority to the chopping block. Official budget cuts began to take effect in late 1989, but the process was agonizingly slow and bureaucratic. Key contractors and specialized factories began to lose their funding, forcing them to halt production of specialized parts like the thermal tiles and avionics. The project didn't end with a single dramatic decision. It died a slow, bureaucratic death by starvation. The engineers were still coming to work, but the materials were no longer arriving. Then came the final, fatal blow: the dissolution of the Soviet Union in December 1991. The USSR ceased to exist, and the ownership and responsibility for the Buran program and all its massive infrastructure was suddenly thrown into chaos. The Buran orbiter and the entire Baikonur Cosmodrome were located in the newly independent Republic of Kazakhstan. The enormous assets were now technically foreign property, instantly severing the last fragile links to Russian government funding and the core engineering teams. The pride of the Soviet space effort had become a political orphan. The nascent Russian government, facing economic turmoil and hyperinflation, had zero appetite to invest billions in a project physically located on foreign soil that was born of a defunct ideology. The few remaining funds were channeled into maintaining crucial elements like the Soyuz manned program and the Mir space station. The Great Buran system was left exactly where it stood, the Energia boosters dismantled, the partially built orbiters left to rust in half-finished hangars, and the single successful orbiter, the pride of Soviet automation, placed into storage at Baikonur. It was not a technical failure. It was a failure of the state that created it. The engineering success had merely been too expensive for the Soviet political system to afford. A final, beautiful testament to unsustainable ambition.
With the Soviet flag lowered over the Kremlin for the final time in late 1991, the vast, dedicated infrastructure built for the Buran program, which had consumed the economic lifeblood of the empire, was instantly rendered redundant. The massive specialized facilities at the Baikonur Cosmodrome were abandoned almost overnight. The colossal MIK, Assembly and Testing Complex, large enough to house and prepare multiple space shuttles and Energia rockets, was sealed. The engineers and technicians who had dedicated their lives to the project were suddenly demobilized, returning to an economically collapsing Russia or remaining in Kazakhstan, where the future of the Cosmodrome was uncertain. The runways, built to military precision tolerance to support the Buran's autonomous landing, lay deserted. The Energia launch complexes, representing the height of Soviet engineering, were deactivated. The promise of an era of frequent, reusable space flights gave way to a landscape of sleeping giants on the steppe. The Buran program wasn't just Orbiter 1.01, the ship that flew. It was a planned fleet of 5 operational orbiters, each in various stages of completion across the factories of the former Soviet Union. The fate of these sister ships was varied and often tragic. Orbiter 1.02, named Ptichka, Little Bird, was 95% complete and sat awaiting final avionics installation. Its hull remains intact, but was left vulnerable to the elements in its vast hangar. Other orbiters, still designated by their construction numbers 2.01, 2.02, 2.03, were either dismantled or used for destructive testing. The most painful irony was that some were used for firefighter training or sold for scrap metal, the ultimate humiliation for vehicles designed to pierce the heavens. The cost sunk into these incomplete vessels was staggering, representing decades of national effort and a massive misappropriation of resources that disintegrated into scrap and improvised museum pieces. The sheer physical footprint of the failure was immense, scattering pieces of the dream across 2 continents. The single, successful spacecraft, Buran Orbiter 1.01, which had performed its perfect automated flight in 1988, was deemed the most historically valuable. It was carefully wheeled into the massive Hangar 112 at Baikonur, which was then controlled by the new Kazakh owners of the Cosmodrome.
Hangar 112 was the primary launch preparation facility, designed to be immaculate and pressurized. However, with the collapse of Russian funding, basic maintenance stopped. The climate control system failed. The Buran, built with cutting-edge materials to survive the heat of atmospheric re-entry, began to succumb to a more mundane enemy: dust, moisture, and rats. The space shuttle sat there, covered in thin plastic, stored next to a test inertia rocket. The pride of a superpower was relegated to a dusty shelf, essentially abandoned in foreign territory. For the engineers who built it, this image was heartbreaking. The technology that proved Soviet superiority was being consumed by neglect. The final, degrading phase of the abandonment began in the 1990s. With the fall of the Soviet Union, the Baikonur Cosmodrome became a site of looting and vandalism. Security funding evaporated, and the vast, isolated complex became an easy target. Local thieves and disgruntled workers stole copper components, aviation wiring, and even non-essential equipment panels from the hangars. The MiK, though too large to be dismantled, lost windows, metal parts, and valuable equipment. What the Cold War could not destroy, the post-Soviet corruption and looting were dismantling piece by piece. Meanwhile, the Buran 1.01 continued in its abandoned sleep, untouched by thieves due to its massive size and complexity, but slowly deteriorating under the dust and the structural stress of neglect. The unique piece of atmospheric re-entry technology in the world was being destroyed by leaks in the ceiling and rust. What was meant to be the future of Soviet space exploration was now a skeleton in a foreign desert, awaiting a final and far darker fate.
For over a decade following its perfect flight, Buran Orbiter 1.01, the only Soviet shuttle to ever fly in space, sat neglected inside Hangar 112 at Baikonur. It was a prisoner of geopolitics, a trophy too heavy for anyone to claim or maintain. While the world moved into the 21st century and space collaboration replaced Cold War competition, the hangar itself, built hastily during the frantic push of the 1980s and poorly maintained by the cash-strapped Kazakh authorities, began to show the terminal signs of structural failure. The roof beams rusted, the concrete foundation shifted, and the desert dust and extreme temperatures took their toll on the massive structure. The absurdity was staggering. The most advanced piece of atmospheric re-entry technology in the world was being destroyed by leaks in the ceiling and rust. The engineers who had poured their lives into the project watched helplessly from thousands of kilometers away as reports of the hangar's deteriorating condition reached For over a decade following its perfect flight, Buran Orbiter 1.01, the only Soviet shuttle to ever fly in space, sat neglected inside Hangar 112 at Baikonur. It was a prisoner of geopolitics, a trophy too heavy for anyone to claim or maintain. While the world moved into the 21st century and space collaboration replaced Cold War competition, the hangar itself, built hastily during the frantic push of the 1980s and poorly maintained by the cash-strapped Kazakh authorities, began to show the terminal signs of structural failure. The roof beams rusted, the concrete foundation shifted, and the desert dust and extreme temperatures took their toll on the massive structure. The absurdity was staggering. The most advanced piece of atmospheric re-entry technology in the world was being destroyed by leaks in the ceiling and rust. The engineers who had poured their lives into the project watched helplessly from thousands of kilometers away as reports of the hangar's deteriorating condition reached Moscow. Their masterpiece was slowly rotting in storage. The final fatal moment arrived on May 12, 2002. A severe storm swept through the Baikonur region, bringing heavy rain and strong winds. The neglected roof structure of Hangar 112, a structure built to withstand the sonic boom of rocket launches, simply gave way. The massive steel and concrete beams collapsed directly onto the priceless contents below. The Buran Orbiter 1.01, the unique vessel that had flawlessly proven the brilliance of Soviet automation, was instantly crushed. The complete energia booster, stored alongside it, was also destroyed.
The debris buried the physical remnants of the Soviet Union's most ambitious space project. The disaster was not merely a loss of property. It was the symbolic execution of the Cold War's final technological challenge. 8 workers within the hangar were killed in the collapse, adding a final, tragic human cost to the program. The physical destruction of Buran 1.01 was a shocking end to the program. For the global community, it was a moment of profound sadness. A unique and successful piece of aerospace history was lost forever, not to a re-entry failure, but to bureaucratic indifference and structural neglect. The cost of the hangar collapse alone was immeasurable. Not only was the orbiter destroyed, but the unique data, the specialized components, and the historical records contained within the immediate area were lost. The destruction solidified the failure of the program, proving that while Soviet engineering could build a superior machine, the Soviet political and economic system could not sustain its use or even its simple preservation. The subsequent cleanup operations found little salvageable material from the original orbiter. The pieces were either melted down or buried. The great technological achievement of the Soviet Empire vanished beneath tons of rubble and forgotten promises. The Buran project, which cost the Soviet Union an estimated 20 billion rubles, equal to hundreds of billions in modern terms, and consumed the talents of over 1 million people, left behind no legacy but a cautionary tale. The single successful flight was a technical triumph that became an economic defeat and ultimately a disaster of neglect. The Buran stands as a permanent monument to ideological vanity, a perfect machine built by a collapsing system to fight an enemy it no longer had the resources to confront. It proves that technological genius, when divorced from sound financial planning and geopolitical reality, is nothing more than a spectacular, temporary flourish. The Buran was ready for space, but the world was not ready for its cost. The mirror image of the American dream became the reflection of the Soviet nightmare.
The Buran Shuttle, built with the genius of 1 million minds, was defeated not by the harshness of space, but by the collapse of an empire. It stands as a monument to technological ambition that became a victim of its own impossible cost. Don't miss the next blunder. If this story fascinated you, hit the subscribe button below and ring that notification bell. We dive deep into catastrophic failures every week. What colossal failure should Billion Dollar Blunders investigate next? Tell us in the comments. Until then, thank you for exploring the end of the space race with us.